Okay, so go ahead and get started. So last lecture was going over the allowance, budgets, and total connected power and all the requirements for that. Some of that comes back into play for the controls for certain exceptions, as well as just general definitions for applying. But something to keep in mind is logic. Um, it really helps if you just think of code controls as just cold logic being applied. That kind of helps you deduce the rationale for it. But there's also a little bit of a informal logic built into it. But mostly we're going to be working off of a conditional statement. If then, hypothesis, then this will happen. If yes, why? If no, why not? But I like to also think of it as just like a logic puzzle. So we're just trying to solve a logic puzzle, and the solution either tells us if we're in compliance, if we're out of compliance. There's a lot of different types of logic puzzles. Those are kind of used and presented in kind of code in various ways, but they're the same thing, just different format. So something to get right off the bat is the dwelling units, residential for multifamily, etc. Those have a separate requirement called out in R404.1. That's basically saying it's going after the luminous efficacy of the fixtures in the residential units. Basically saying you will have a certain threshold. In 2018, it's kind of just implied, hey, do a high efficiency fixture. In 21 and 24, they actually call out and give you a standard for it. And then for the other thing to keep in mind is walk-in coolers, freezers, refrigerated warehouse coolers, those areas. Those have a separate standard as well. And basically, like I just said, with the residential units, they have a certain threshold of luminous efficacy that they want you to hit. And then
just for residential,
for
walking coolers thing?
No, it's commercial. Yeah, sorry. So this is the only residential, which is mostly kind of aiming towards multifamily residential, which is why it references the residential section. But then this is going back to the commercial section, and basically for the walk-in coolers, freezers, there's a luminous efficacy, the threshold they want you to hit, and then there's certain restrictions on where you can put the lights.
Is that because previously there was like an exception for lighting that was provided by the digital for the.
Yeah, those are the exceptions. So anything, yeah, so anything provided by the manufacturer is allowed, and it's actually not counted towards your allowance or your connected power because it's basically not your choice. So these are the mandatories, and it's basically broken up into two paths. So you can either do the prescriptive, which we'll go through in the majority of today's lecture, but then we're also going to talk about luminaire level lighting controls. That's the other option. Basically, it's a simplifying the code compliance for it. So LLCs, luminaire level lighting controls, was created by NEA, the Northwest Energy Efficiency Alliance, who is sponsoring this lecture today, full disclosure. They work with manufacturers to see what they could help do to make a product that would meet the continuing demands of code. It's going to be more stringent, but also needs to apply to more space types. So is there a way to simplify and generalize being in compliance for it? So LLC standard is held by the IES, the Illuminating Engineering Society. So they create the threshold for what is considered LLC. And their threshold is, and theoretically, this is how they model it, is that when code is here, LLC compliance is here, code moves up and LLC moves up. So it's supposed to be straightforward, out-of-the-box solution. The only thing you have to worry about is making sure you're programming the controls correctly. And that's mostly done in the commissioning part. So it's a way to simplify the process. But if not, here are the sections, 405.21 to 2.6. So the first one is going off of your space by space or building area method, calling out the space methods or the space types in your programming schedule. So if you have any of the ones here, you are required to have an occupancy sensor. And so a lot of the controls is broken up into, are you required to have the hardware? If yes, then this is how you control it. If no, see the next hardware section and keep going, because eventually one of them will apply. And then that's how you kind of figure out which controls you need for your space type. So a couple of exceptions. For your warehouse, you're going to proceed to 405.212. The other thing is with an open office area plan within your building, then you will have to reference an additional section. There's some requirements for that. But the control function is automatically turn off within 20 minutes after everyone's left the space. They shall be manual or controlled on to automatically turn on to no more than 50%. I don't know about you, but a lot of occupancy sensors in rooms don't do that. They turn it on to full. There's an exception for that for safety and security reasons. But the implication for code is that it's supposed to be saving energy. So we don't want it to turn on more than 50%. Should require an occupant override to do that.
I think that what we've been mostly doing is just going to manual on versus the 50%.
Okay, yeah. So yeah, and then that's the manual control to allow occupants to turn off. But theoretically, that's how it's supposed to work. In practice, people will do what people do. So the exception, public corridors, stairways, restrooms, primary entrances or lobbies, and then areas that would be engaged to the safety or security of the room with the building occupants. So that's more of the informal logic where it's like, hey, you decide, you're the designer, you know best, apply common sense. But what if you're a warehouse? So lighting in aisleways and open areas shall be controlled with occupancy sensors that reduce lighting power by not more than 50% when it's unoccupied. What that means is that all the fixtures in the alleyway need to power down to 50% or less. So depending on what you're storing or how frequently people are going to be accessing those storage areas to pick and pull, you may want to keep it at just 50%. So there's more time and less transition. Or if it's more infrequently, then maybe powering down to 0 is probably a better option to save energy. You don't get the double dip. Each aisleway has to have its own independently controlled occupancy sensor. So if there's two area connecting two aisleway, then you need 3 occupancy sensors. So well, let's say there's an open office area in our warehouse. So first question you got to ask is the area greater than or equal to 300 square feet? If no, then refer back to the original section for how to the normal control function for the sensors. If yes, then you have to comply with this, where basically you're limited in the general lighting of your open office area to 600 square feet or more. So for example, if you have an open office area of 800 square feet, you'll need at least 2 control zones. You can have 3, you can have 4, but at minimum, you need 2. So, and then it basically has the same control settings for, the original areas, just, requiring you to have a little bit more because we want to try to capture a little more granularity for the energy savings. So last vacancy can be between 0 and 20 minutes. I don't know if it will be a problem with a lot more digital control systems where occupants can have more access to it. If building facility managers or occupants themselves will override and say, actually, I want it to be 30 minutes. I want it to be 45 minutes. I don't know the degree of level of control you can have after the space has been occupied. And then lights must be reduced to 20% output or less. So. The control shall be configured so that general lighting power in each zone is reduced by not less than 80%. Code really writes it this way because it has to be an absolute, but I like to rewrite it. Basically, lights must be reduced to 20% output or less. Control functions that switch control zones lights completely off when the zone is vacant meet this requirement. So if you just want to say, hey, we're not going to dim to a certain threshold, it's just going to go to full off, you're good to go. But it has to do so in a uniform manner if you're going to dim. So you can't have 2 lights dim and then have the other 4 start dimming. So it has to be uniform. And then for daylight, basically daylight has to check with the occupancy sensor. So say there's sufficient daylight in the area, but then a cloud happens and there's not sufficient daylight. So then the sensor would read, hey, we need to turn the lights on to meet the illumination threshold level. It needs to check with the occupancy sensor first to say, hey, is there occupancy in this area? If yes, then okay, raise lights. If no, then hey, stand out. So just applying a logic tree for the control functions, that's all. And then so basically, if you answered no to I don't need an occupancy sensor for this space, then you move on to time switch controls. These are basically occupancy sensors hidden in the background. They work off of scheduling, so building automation, light scheduling, things like that. They're very commonplace now. But typically not really noticed by the occupants unless they're in the building at the time when, you know, hey, it's the start of the day, or hey, it's the end of the day, things like that. So each area of the building that is not provided with an occupancy sensor complying with that section shall be provided with a time switch control. And then there are exceptions where a manual control provides light reduction. So those exceptions are space where patient care is delivered, where automatic shutoff would endanger occupant safety or security, light intended for continuous operation, i.e. corridors, walkways, and then shop in laboratory classrooms. So again, a little bit of an informal logic. So you get discretion on where to apply the exception as needed. Each space provided with a time switch control shall be controlled very similar to occupancy sensors, unless the light reduction controls space is required to have it. And if it is required, then it shall be to reduce the connected lighting load in a reasonable uniform pattern by at least by not less than 50%. Basically, you have to let people dim the lights. So you need a dimmer switch. Lighting reduction shall be achieved by one of the following approved methods. So basically this applies to fluorescent lighting, which we don't really have a whole lot anymore. But basically that's where it's the lamps and the luminaires in the middle one, and or switching and the step dimming. It's not required in daylight zones with daylight responsive controls. So for some reason you're working on a historic building that has fluorescent lighting, this will come into play. Shall include an override switch device capable of the following. Basically, it has to have a certain level of sophistication or smart features. Have a minimum 7-day clock. Be able of setting 7 different days. That could be work day. It could be a typical week, Monday through Friday, etc., or holiday day, things like that. Incorporate an automatic holiday shutoff feature, which basically overrides for 24 hours and then goes back to the lighting schedule. So that's if you have a holiday or something that wasn't accounted for. Have program backup capabilities, which prevents the loss of the program, so someone doesn't have to come back out and recalibrate and commission the system. And then include an override that complies with the following. The override switch shall be a manual control. So that is going to come up in pretty much every section for lighting controls, is that you're going to need to have manual control, and then occupants need to have ready access to it. Ready access means I don't have to do anything other than walk up and touch it. So there's no friction preventing me. There's nothing I have to do. The override switch, when initiated, shall permit the controlled lighting to remain on not more than 2 hours. Any individual override switch shall control the lighting for an area not larger than 5,000 square feet. So again, keeping the area in mind. So building area method, space by space. Part of the reason why I would like you to do it first is because you have all that data assembled and organized, and now you just pull and reference. And then exceptions are within mall concourses, auditoriums, sales area, manufacturing facilities, sports arenas, things like that. The time limit shall be permitted to go above 2 hours, provided that there is a captive key device, so override. The area controlled by the override shall not be limited to 5,000 square feet, provided that such an area is less than 20,000 square feet. So there's a range, which, you know, makes sense with malls, auditoriums, sports arenas, etc. Where provided with manual control, the following area are not required to have a light reduction control. So spaces with only 1 luminaire with a rated power of less than 100 watts. Spaces with use less than 0.6 watts per square foot. Corridors, lobbies, electrical rooms, or mechanical rooms. Basically, there's not really enough there to care, so we would be tripping over dollars to pick up dimes. So daylight responsive control, my favorite, the one that I get the most questions on. So daylight is broken up into 2 types right now, side-lit zones and top-lit zones. Okay, and so you have to identify if your building has those, and then draw the area to calculate it, but also identify its location, because that's important for exceptions, and basically go from there. But something to keep in mind, before you want to try to identify all your daylight areas before you start placing lights in your space, even though, it's pretty obvious for some space types where a light should go. Because spaces with a total of more than 150 watts of general lighting within the side lit zone or the top lit zone, basically says you will have to put a daylight responsive control, a photo controls into that zone. So certain exceptions apply. So spaces in healthcare facilities where patient care is being directly provided, lighting that is required to have specific application controls in accordance with 405.24. So basically that's like all of your retail and display lighting, cabinetry, under lighting, stuff like that. Like, hey, we're not worried about that. That's going to turn on and be on because it's for show. So silent zones on the first floor above grade in groups A2 and group M occupancies. And then this final exception it's important to keep in mind, which is why the last lecture I showed you all the ways you could do it really early on and estimate, is because to get this exception to not have any photo controls in your building, you have to use the building area method only. So not the space by space. So you're getting less wattage in the building area method. But then also you have to, if you are applying the C406 reduction, then it also applies here. So you have to take that 10% off the top. And basically you have to compare your normal lighting power allowance multiplied by a factor of your uniform daylight zones versus your total building area. And so, and if that is less than your lighting power of your interior, total connected interior power is less than your lighting power adjusted from that daylight factor, then you don't have to do any photo controls. And the last caveat is that it has to be a new construction. So new construction, building area method, do the reduction if you're applying for it. And then your total connected power has to be less than your lighting power adjusted, accounting for your daylight areas. So.
Okay, but it also seems like it's pretty difficult.
Yes, and so here's an example of me breaking it down. So last one I used the high school. So that building area method is 0.81. So, and let's just say our lighting power adjustment is 210. Then our say, so the way I like to use it is a way to kind of keep in mind of like, if this, then that. So what do I have to do to meet compliance? And so for this example, I just said, hey, let's take 5% of the area and say that's going to be daylight, just because, we have fenestration and windows in our building. And then the total area is 250,000. So you plug that in. So our lighting power normal times 1, or in the parentheses, so 1 minus 0.4 times our daylight area, which is the 5%, so 12,500 divided by 250,000. So that says we have 196,000 watts is our adjusted. So if I'm doing this in the early design phase, I basically frame it as, so we need to keep our total connected interior lighting power below 196,000 watts. If I can do that, then great. If I can't, then I'm like, okay, we got to pivot and do the space by space method. But at least we tried and we know that path of compliance didn't work out. So try to treat it as what if. So what if we had 5% of the area or 10% of the area? And so this doesn't, so whether you put a photo control cell in that daylight zone doesn't matter for this calculation. If it's considered side lit or top lit, then it gets put into this calculation. So the daylight area, the uncontrolled daylight zone, see it says uncontrolled, that's not gonna be 0. Okay, so if that was 0, then this will come out and you would just multiply your allowance by 1, which doesn't do anything. I guess, sorry, any questions on that? I know that equation always throws people for a loop. And they're usually very disappointed because they're like, I should have started it earlier so I could be in compliance.
Back at one slide right now. So you're applying efficiency reduction to C406 and mass apply it.
So see, yeah, so there's 6 options, and 2 of the options deal with lighting. One deals with control and one deals with the power allowance. And so that's basically saying it will be not greater than 90% of what your allowance is. So basically saying, hey, take a 10% haircut. So if you are applying that efficiency, it applies here. So you'll have to make the judgment call of like, hey, do we want to do that efficiency center? Because out of those 6 options, you have to choose one of the 6. You can do more if you want, but you have to do one of them. So then you basically.
So you're applying efficiency reduction. Like what?
I got it right here. 1 second. Additional efficiency package options is the section. And so number 2 is reduce lighting power in accordance with section 406.3, which is the power allowance section, and then enhanced lighting controls. Enhanced lighting controls in accordance with section 406.4. So those are the 2 lighting ones.
So if those are options. Right?
C406.1 requirements, buildings shall comply with one or more of the following.
So I thought you were saying if you were.
So yeah, if you're implementing that, and usually people will choose the lighting because it's the easiest.
If you're implementing
Yes.
the building area method, then you have to choose. I get it. Sorry. Yeah.
Okay.
Have to apply those.
Yes, so you have to basically go through the checks and like, am I building area method? And if I'm doing this compliance, do this. And then if you get all the check marks, then it's like, okay, now I can solve the equation and see if I will get the benefit. So let's talk about the silent zone. Where the fenestration is located in the wall, the silent zone shall extend laterally to the nearest full height wall up to 1 point height from the floor, et cetera, et cetera. It's a better visual example. So this is how you do it. So we have a window here in our wall. And so we're going to take from the floor to the top sill. That's going to be our H that we're going to apply. That's going to be our depth, how far we go into the space from the fenestration. And then as a default factor, you get to go 2 feet left or right from the border of the sill until you hit a full height wall, or whichever is less. So you can see on the example here down below, that could be 1 foot, that could be 1'9", you get the full credit. But here you can see there's like this is 5 feet. So we have 2 and 2 for 4. So if you space your windows properly, you can maximize your daylight zone. You can also do the inverse so that you can limit your watts in the daylight zone so that you're not required to have photo controls. So this is not to scale. Obviously, there's not going to be this many lights in the space, but I just want to kind of give you an example of how you would calculate the zones. So I like to break them up: daylight zone A, B, C, D, etc. And then I have, just normal A, B, C, and whatever. It's not daylight, then I know it's not in the primary daylight zone. Not that there's not going to be daylight, but it's not daylight that we care about right now. So another exception, where I get that, I'll come back to that. Basically, I like to reorder this and say basically do the checks. So do 1 through 3. So the visual transmission of the fenestration is not less than 20.2, 20%, sorry. The area of the fenestration is not less than 24 square feet. And then the distance from the fenestration to any building or geological formation that would block access to daylight is greater than the height from the bottom of the fenestration to the top of the geological formation. Yeah. So
especially the one about,
yeah, basically, if none of these, so if you violate any of these or you're non-compliant with one of these, then it's not a silent zone. You don't have to count it. So keep that in mind.
Like when we look at a plan, we're just going around looking for windows.
Yeah.
And we're not really like the 24 square feet is actually kind of big. It's not huge, but like there's a lot of windows that we would just see it on the plan. It might just be a little call it the
yeah, that's why I like to pull out the schedules first, because the plans are a little misleading. So I like to do schedules first, and then we're taking the data from our schedules and applying it to the plan. So here's a visual example of that. Basically, you want, so 50 feet is less than 80, so yes, but if it's 90 feet, it's not less than 80 feet, so no. Yeah.
So it's like I go to over, let's say. It says, you said your advantage, like you have less than plots. They're all good,
Mhm.
but if you do have more than a plot, say, got all, and you extend past 2 feet, and just make 1 feet continuous zone.
So there's no double dipping. So the way the main exit is that you would have to have this be a 4-foot wall so that the border touches. Yeah, it becomes a contiguous area.
Yeah.
But say, this was only 3 feet, if I gotta go 2 feet that way, 2 feet that way, I still only get the 3 feet. So there's no double dipping. Probably a better example is if we put a window here, right? And say it's a 7-foot, high window sill height, then goes 7 feet from the air, and it would, double dip on its own, this area, you still only count the area once.
Right. So what he's saying is those would have to be 2 separate daylight zones.
Yes. Yes, so you can control them with the same sensor if they're part of the same part of the correction, provided it's limited to the 150 watts. So the moment
And how are they different daylight zones?
so
If they're
they're
calculated
calculated,
sensor.
it's the way you do the math for the watts. So, but I have a slide for that. All right. So here we go. Lights in silent zones in accordance, facing cardinal direction orientations within 45 degrees of due north, east, southwest shall be controlled independently of each other. So it's based off of orientation. But then the exception is up to 150 watts of lighting in each space is permitted to be controlled together within a daylight zone facing a different cardinal direction. So say this is south and this is west. So if this zone is controlled, you don't need to put 2 photo controls here, one
Yeah,
more.
so let's say you have 2 daylight zones there, you have 1 photo cell controlling both of them. How are they separate zones? What's making them separate zones?
That are not configured.
Control wise,
Control wise, nothing. Control wise goes by cardinal orientation.
because I've always taken that to be that those need separate controllers because they're separate daylight
You can.
zones.
That would
No,
be-
that's how I've always interpreted it.
Oh, that's the way we prefer you to do it. So thank you for doing it that way. But
Cost-wise, it's
yes, so that's why we have the cardinal orientation is so that you can limit the amount of sensors you need to put in some. So it's better because, daylight is gonna behave differently coming through this window versus this window at different times of day. So if you have one sensor controlling both of the zones, then, it's not as granular, after the cluster, if you say it's maybe not, it's not like the volume over the course of the day, et cetera.
um.
Yeah, so it doesn't tell you how many sensors you need per zone. The sensor requirement goes off of the cardinal orientation.
You have to be focused on separately. That's the part that's getting me, because to me, daylight zone. In my head means separate.
So the separate thing comes from top lit versus side lit. So top lit is not allowed to be controlled. So if we had, say we had a skylight over here in this zone or in an overlap, so this would take this area. This light have to be controlled independently with the top lit zone and cannot respond to the photo control or tele control in the other zones. Does that make sense?
Yeah, it does.
So that's the only distinction it makes in the control section for daylight zones being controlled independently outside of cardinal orientation. Because sometimes people would double dip and say, hey, we got one sensor, and oh, hey, this is part of daylight being when it's from the skylight over here or the 3rd story, so it counts.
So then. I've always been trying to encourage folks to have the less than 4 foot distance so that they're in the same zone, so that I can have less control. I don't actually need to do that.
Oh, but you would be maximizing your daylight harvesting area. So if you're going for any incentives from, say, Idaho Power or something, that's a benefit for that.
I mean, you still get the same amount of area, 2 feet on either side of the window.
Yeah, but you could theoretically fit a whole extra daylight zone depending on how the space is arranged. Like if it's an open office, a continuous area, and you want that entire area.
But that entire area can be all controlled together anyway, for the same cardinal zone,
Yes,
cardinal direction.
yes.
So I don't see missing some point of how
Just
beneficial.
It's just min-maxing the surface area so that you would get the highest rate of return for an incentive. That's really it. It's just nitpicking. Anything else on side-lit zones?
Not yet.
Okay, so top-lit zones, this is basically how you draw it, but I like to give the visual example. So there's two versions of a top-lit zone, something called a roof fenestration assembly. Why it's called that and not a skylight, I have no idea. Literally, there's dozens of sections of the code that call out skylights by name and tell you how to treat them and whatnot, but for some reason, not in the daylight section. But basically we're gonna go, instead of going with the floor to the top sill height, now we're going from the floor to our ceiling height. We're gonna take that variable and apply a factor to it. So going from each cardinal direction from the borders of our skylight fenestration, you're gonna apply 0.7 times your ceiling height, and that's gonna give you the daylight zone. And there's still restriction, so any obstruction larger than 0.7 the ceiling height. So whatever, anything larger than that, you can't go over. So it's considered obstruction. It's kind of like the full white, where you get the 2 feet, and then if it's less than that, you gotta stop. So same thing. And then we also have a rooftop monitor. So this one's a little more complicated, because we're taking the seal height, or sorry, the ceiling height, and then we're also taking the bottom seal height of our rooftop monitor. So from the floor to the bottom seal of our rooftop monitor. And then the daylight zone is going to project for where we are throwing the light with our rooftop monitor. And same thing about the obstruction. If it's 0.7 of the ceiling height for height, its height, then it stops the zone. And then some checks to do before you start drawing though. Direct sunlight is not blocked from hitting the roof fenestration assembly at peak solar angle on the summer solstice by buildings or geological formations. So similar to our side lit zone, but we're just concerning about how light is hitting our roof plane. The product of the visible transmission of the roof fenestration assembly in the area, the roof of the opening of the roof fenestration assembly divided by the area of the top lit zone is not less than 0.008 for our effective aperture. So basically BT times RO divided by TZ area will give us our effective aperture. You honestly have to try to not be in compliance with that. But for solar angles, like Weather Spark, they'll give you a table for it. You do need a membership to download data from it. My opinion, it's worth it. So if you're going to be accessing the data that way, by all means. And then daylight responsive controls. So lights in top-lit zones shall be controlled independently of lights in side-lit zones in accordance with their section. Daylight responsive controls within each space shall be configured so that they can be calibrated from within a space by authorized personnel. Calibration mechanisms shall be in a location with ready access. So basically, allow facility or whoever, basically they shouldn't have to dig around or have to do any construction work to calibrate the lights. And then here are some of the extra requirements for the control functions that we went over. Shall be configured to completely shut off all controlled lights. Where located in offices, classrooms, laboratories, library, reading rooms. Responsive control shall dim lights continuously from full light output to 50%, 15% of full light output or lower. Any other questions on the cardinal direction stuff? So specific application controls. So the following lighting shall be controlled by an occupancy sensor complying with that, or the time switch control, which is that section for the controls. In addition, a manual control shall be provided to control such lighting separately from general lighting in the space. So display and accent lighting, display cases, supplemental tax lighting. This one's kind of weird, including permanently installed under the shelf or under cabinet lighting. Sometimes that's not permanent, so it's kind of hard to, you have to make a judgment call whether it is permanent or not. Typically the best case is like if it's coming installed from the manufacturer, then it's definitely permanent. But for the lighting power allowance and total connected power, you are responsible for occupants or building owners bringing in additional lighting for it. So just keep that in mind. Lighting equipment that is for sale or demonstration and lighting education. So like these 4 lights and the 15 we have out there, because this is university, I do use those for educational purposes. I can have those exempt. Sleeping units shall have control devices or systems that are configured to automatically switch off all permanently installed luminaires or switch receptacles within 20 minutes after all occupants have left the unit. So mostly multifamily is what it's targeting there. Some exceptions are and this is mostly geared towards hotels, lighting and switch receptacles controlled by card key controls.
That's new, yeah.
No.
This is not residential, but this is sleeping units. And then I get it. Okay. Sorry.
Yeah. Space where patient care is directly provided. And then basically, permanently installed luminaires within dwelling units shall be provided with controls complying with the occupancy sensor or the time switch ones. The lighting for non-visual applications such as plant growth or food warming shall be controlled with the time switch complying with the time switch control section that is independent of other lighting within the room or space. And also keep in mind, plant growth and food warming, you don't have to count as your total connected interior power, but you do have to control it.
The controls, that's only the controls for the plant lights.
Nope. No. It definitely gets an overhaul in 2021, like a big one. Point where I'm like, oh God, I'm gonna get way too many questions when we have to start implementing that. Within manual controls, so where they are required, they shall comply with the following. They shall be in a location with ready access to occupants. They shall be located where the controlled lights are visible and shall identify the area served by the lights and indicate their status. So i.e., you can't have like what we used to have where if you wanted to turn on and off our lights, you had to go in the hallway, down around to a random corner, and then press the button. So none of that. Should be fairly straightforward and obvious.
I guess, the accessibility or,
The ready access.
the ready access.
Yeah.
Or like schools or other places where they have like the switches. Where switch is there. I guess, someone can get to it, but it's not accessible in the way that we can operate it, they don't have a key for it.
Well,
so where I guess that's
So the key word in here is occupants. So the teacher is an occupant. A parent visiting the school is not an occupant. I would say student is kind of a gray area, but I mean, it's also a student. You don't really trust the students with control of things, my opinion. But so it means like the occupant. Would be if you were in an open office, then it would be everyone kind of needs to have the key card access to light switch because they are an occupant. So I would just take a look at the term occupant and apply that.
okay. That makes sense.
And yeah, with schools, it's getting really difficult for access and programming and everything like that. So yeah, good question. Thank you. Any other questions on interior? We're gonna kind of shift gears to the exterior. So exteriors pretty straightforward. We have 4 sections: daylight shut off, decorative lighting shut off, lighting setback, and interior. Oh, that one's not correct. Exterior lighting power requirements. So exterior lighting system shall be provided with controls that comply with sections I just talked about, and decorative lighting shall comply with their own control section that has additional subsections for it. We'll get into that. Some exceptions are lighting for covered vehicle entrances and exits to the building and parking structures where required for eye adaptation. Lighting controlled from within dwelling units. I wasn't supposed to do that. Daylight shut off. Lights shall be automatically turned off when daylight is present and satisfies the lighting needs, i.e. you're gonna have a photo cell there, which basically says, once I get to a certain threshold, hey, turn off, sun's up. Decorative lighting shut off. Building facade and lighting, landscape lighting shall automatically shut off from not later than 1 hour after business closing to not earlier than 1 hour before business opening. So basically incorporate it into your time switch controls or your building scheduling. Lighting setback, lighting that is not controlled in accordance with the section we just talked about shall be controlled so that the total wattage of such lighting is automatically reduced by not less than 30% by selectively switching off or dimming luminaires at one of the following times. So from not later than midnight to earlier than 6 a.m., from not later than 1 hour after business closing to not earlier than 1 hour from business opening, during any time where activity has not been detected for 15 minutes or more. And then time switch controls for your exterior lighting, which is pretty much your go-to. They shall have a clock capable of being programmed for not fewer than 7 days. They shall be capable of being set for 7 different day types per week, basically the same as interior time switch controls. Shall incorporate a holiday setback feature, and they shall program backup capabilities so that it can be restored for not less than 10 hours after power is interrupted. So any questions on exterior lighting? Okay. So that's the end of C405, but wait, there's more. There's additional sections that apply for lighting. The one I'm going to go over most is 402.4, which deals with, so 402 deals with building envelope. So specifically, we're going to go over the fenestration sections in there. So ask your mechanical engineer if they will be applying this portion of the code to their project. I say that because it is prescriptive. So building envelope, fenestration, maximum U factor, and solar heat gain coefficient requirements. So for us, it goes by climate zone. So we're 5 and marine 4. We're technically just 5, but they throw in marine 4 with us. So it's going to give you your U factor for fixed, operable, and entrance doors. Your solar heat gain coefficient is going to be based off of your orientation. This changes in 21 and 24. That's no longer a thing, but basically going off of your projection factor for so and then N, so south, east, west, and then north. And then skylights have their own U factor and solar heat gain coefficient. So maximum area, the vertical fenestration area, not including opaque doors and opaque spandrels, shall not be greater than 30% of the gross above grade wall area. The skylight area shall not be greater than 3% of the gross roof area. So now we're taking all our daylight zone calculations because we found out where the windows were and if they qualify and not. And now we're gonna, check if like, hey, are we violating fenestration compliance? So increase vertical fenestration area with daylight responsive controls. So basically, the main thing to ask yourself when you get to the section is, do you need the extra 10%? If you do, then yeah, go through this prescriptive requirement. If you don't, then skip it. But in climate zones 1 through 6, not more than 40% of the gross area above gross above grade wall area shall be vertical fenestration, provided that all the following requirements are met. So in a building not greater than 2 stories above grade, not less than 50% of the net floor area within a daylight zone. In buildings 3 or more stories above grade, not less than 25% of the net floor area is within a daylight zone. So that calculate that exception we had for number 4 using the building area method, where we compared our uncontrolled daylight zones to our total area. That comes back into play here. We're just not that equation, but those 2 variables we used for it. So daylight responsive controls complying with the sections we went over, and then visual transmission of the vertical fenestration is not less than 1.1 times the solar heat gain coefficient. Exception, you can apply as if the fenestration that is outside the scope of the NFRC is not required to comply with item 4. I'll be honest with you, I have no idea what the NFRC 200 is. That's outside my purview. So, increased skylight area with daylight responsive controls. The skylight area shall not be more than 6% of the roof area, provided that daylight responsive controls in the appropriate section are installed in top lit zones. So basically, if you're fully complying with the top lit zone and the daylight control function features that are associated with that, you get to increase your skylight area. So before it was 3, do this, it's 6. Minimum skylight fenestration area. Again, you kind of have to try to not meet this requirement, in my opinion. But the math can be a little confusing, but so you still gotta show your work and do it. So in an enclosed space greater than 2,500 square feet in floor area directly under the roof with not less than 75% of the ceiling area, with a ceiling height greater than 15 feet and used as one of these following spaces. So do that checklist first. Then the total top lit daylight zone shall not be less than half the floor area and shall provide one of the following. Okay, so basically your top lit, you have a ceiling on the minimum area your top lit daylight area should be for that skylight. Minimum skylight area to top daylight zone not less than 3%, where all skylights have a BT of not less than 0.4 as determined in that section.
Because the way we do, like, we do our compliance with top check, we're basically only looking at the electrical side of things.
Don't,
They have it like in contract, in the envelope portion, you know, they have to like check that they've looked at this? Like the architects,
That is a good question.
curious if there's a.
I believe contract should trigger it.
It's not something that we see from our end on the lighting side of things, so
But
it's like.
yeah, you basically have to try to not be in compliance. It's more of like just, hey, did you buy the skylight from an appropriate manufacturer or distributor?
Putting any skylights.
Yeah. But basically,
I'm sure they're aware of it.
yeah, I do get questions occasionally on this, and it's more of like, hey, how long has this been there? Also, how do I do this?
There's
so-
probably other architectural codes that also require this, so they're like.
Yeah. Yeah, this is specifically with the energy one, but yeah. The thing that kind of trips people up most is the WF for it, the well factor, because it goes off of the light well. Most people don't really, not a lot of skylights have those nowadays. So that's kind of what trips people up. But to give you an example, and then the exceptions are skylights above daylight zones of enclosed spaces are not required in buildings in climate zones 6 through 8. So basically it's hot, there's a lot of sun exposure, so we're not gonna nickel and dime you, you're getting plenty of solar exposure. Spaces where design general lighting power densities are less than 0.5 watts per square foot. Areas where it's documented that existing structures or natural objects block sunlight. So basically you're taking your SDA, daylight analysis throughout the year and applying and seeing if it's enclosed areas covered for more than 1,500 daylight hours per the year, with the requirement between 8 a.m. and 4 p.m. Spaces where the daylight zone on the rooftop monitor is greater than 50% of the enclosed space floor area, i.e. atriums. Spaces where the total area minus the area of the side-lit daylight zones is less than 2,500 square feet, where the lighting is controlled in accordance with the control section. But a quick reminder for skylights, the anatomy of a skylight, this is what it looks like. And so number 2, the throat or the light well is what that's referring to, is that distance. So depending on the distance, if it's greater than one variable, then use this variable. If it's less than it, then use this other one. Basically what it goes through. And then, oh yeah, also keep in mind the spacing skylights. You want a little bit of overlap because we're going for uniform illumination. But yeah, the other thing about skylights is the haze factor. So skylights in the following spaces shall have glazing material or diffuser with a haze factor greater than 90% when tested in accordance with ASTM D1003. Exception, skylights designed and installed to exclude direct sunlight entering the occupied space by the use of fixed automatic baffles or the geometry of the skylight and the light well. So basically, have you arranged it so the light just bounces and then it's diffused that way rather than direct access and then having material diffuse it for you. The maximum U factor and solar heat gain coefficient for fenestration shall be specified in table C402.4. That's the one I showed you earlier. The window projection factor shall be determined in accordance with equation 4-5, which is basically PF equals A over B. And then where different windows or glass doors have different PF values, they shall each be evaluated separately. The reason why I skipped the equation is, again, better just to show the visual example. So basically, you're taking the bottom sill to the bottom of the overhang, and then you're going right up to the actual fenestration surface itself, out to the perimeter of the overhang. That's how you're getting the value. So say A is 26 inches, B is 72 inches, keeping the same units. So our PF would be 0.36 on 1. So then referencing the table, in that we can see our southeast west. So heat gain coefficient should be 0.46. And then for north, it's 0.56. So increased skylight, so heat gain coefficient and U factor in climate zones 1 through 6, that's us. Skylight shall be permitted a maximum solar heat gain coefficient of 0.6 where located above daylight zones provided with daylight responsive controls. Where skylights are installed above daylight zones provided with a daylight responsive control, a maximum U factor of 0.9 shall be permitted in climate zones 1 through 3, and a maximum U factor of 0.75 shall be permitted in climate zones 4 through 8. So that one's us. And then last, we have the area weighted U factor. An area weighted average shall be permitted to satisfy the U factor requirement for each fenestration product category listed into the table I showed you earlier: operable, fixed, door, etc. Individual fenestration products from different fenestration product categories listed in that table shall not be combined in the calculating weighted average U factor. And that's all I got for you.